Hello students. Welcome to our Senior Secondary School 2 Physics lesson. Today, we will be learning about equations of uniformly accelerated motion. But before we proceed, let's quickly recap what we learned in our previous lesson. In our previous lesson, we defined the concept of parallel forces. We identified the types and solved calculations on parallel forces. We also went ahead to explore Archimedes' principle. And it was exciting. Before we begin today's lesson, let's take a quick look at our lesson objectives. By the end of today's lesson, you will be able to define uniformly accelerated motion, explore the three equations of motion, and solve some calculations on uniformly accelerated motion. Are you ready? Let's proceed. Uniformly accelerated motion refers to motion where the acceleration remains constant over time. This type of motion is common in physics problems involving freefall, projectiles, or vehicles accelerating at a steady rate. Key variables in uniformly accelerated motion. 1. Initial velocity, the velocity of the object at the start of the motion, measured in meters per second. 2. Final velocity, the velocity of the object at the end of the motion, measured in meters per second. 3. Acceleration, it is the rate at which the object's velocity changes. It is positive for speeding up, negative for slowing down, and is measured in meters per second squared. 4. Displacement, it is the total distance covered in a specific direction, measured in meters, m. And 5. Time, it is the duration of the motion, measured in seconds. Each variable represents a key aspect of motion under constant acceleration. These variables are interconnected, meaning changes in one affect the others. Now let's explore the three equations of motion. These equations describe the relationship between the variables. 1. First equation of motion. V equals U plus AT. This equation describes how the final velocity changes, based on the initial velocity, the constant acceleration and the time the object has been accelerating. It is used when you need to find the final velocity, after a certain time with constant acceleration. Example. A car starts from rest, U equals 0, and accelerates uniformly at 3 meters per second squared, for 4 seconds. What is its final velocity? Solution. Substitute the values into the equation. V equals U plus AT. V equals 0 plus 3 meters per second, multiplied by 4 seconds. Seconds cancels out seconds, which is 0 plus 12 meters per second. That gives us 12 meters per second. Therefore, final velocity equals 12 meters per second. Now, the second equation of motion. S equals ut plus 1 over 2, at squared. This equation calculates the displacement of an object based on its initial velocity, acceleration, and the time for which it moves. It is used to find how far an object travels during acceleration. Example. A ball is thrown upward with an initial velocity of 10 meters per second. How high does it go after 2 seconds, assuming acceleration due to gravity is a equals minus 9.8 meters per second squared. Solution. Here we are looking for the displacement. Substitute the values into the equation. S equals ut plus 1 over 2, at squared. S equals 10 meters per second times 2 seconds, plus 1 over 2, bracket minus 9.8 meters, per second squared. Bracket 2 seconds squared. Seconds cancels out seconds. Let's break this down. S equals 10 meters times 2, which is 20 meters, plus 1 over 2, bracket, minus 9.8 meters per second squared, and 4 seconds squared. I know this might be tricky, but stick with me. Let's calculate the value of plus 1 over 2, bracket minus 9.8 meters per second squared, and 4 seconds squared, step by step. First, multiply minus 9.8 meters per second squared by 4 seconds squared. Second squared cancels out second squared, which equals minus 39.2 meters. Then multiply plus 1 over 2 by bracket, minus 39.2 meters, which gives us minus 19.6 meters. Back to the equation. S, which is displacement, equals 20 meters, which was our result from multiplying 10 meters by 2 seconds. Minus 19.6 meters, which gives us 0.4 meters. Displacement equals 0.4 meters. The ball has almost stopped moving upward at this time. Don't worry if it takes time, understanding comes with practice. Now the third equation of motion. V square equals U square plus 2as. This equation relates the final velocity, initial velocity, acceleration, and displacement, without involving time. It is used when you want to calculate displacement or velocity but don't have time. Example. A car traveling at 20 meters per second comes to rest, V equals 0. After skidding 50 meters. What is the car's deceleration? Solution. We are tasked with finding the car's deceleration using the third equation of motion. Listing the variables. U equals 20 meters per second. V equals 0 meter per second. S equals 50 meters. And A equals deceleration in this case, so it will be negative. Substitute the values into the equation. V square equals U square plus 2as. 0 equals 20 meters per second squared plus 2 times A times 50 meters. 0 is equal to 20 squared, which gives us 400 meters square, second square. And 2 times A times 50, which gives us 100 A in meters. To solve for deceleration, subtract 400 meters square, second square, which becomes 0 minus 400 meters square, second square, equals 100 A in meters. Now we divide minus 400 meters square, second square by 100 meters. Meters cancel meters. That gives us minus 4 meters per second squared. Therefore, deceleration equals minus 4 meters per second squared, negative because the car is slowing down. You're getting there. Take your time if understanding doesn't happen immediately. Now it's your turn. Here are 2 quick practice problems. Give them a shot. Remember to pause the screen and solve the problem. Great job so far. Let's recap. The equations of uniformly accelerated motion help us analyze motion. These equations describe the relationship between velocity, displacement, acceleration, and time. In our next lesson, we will be learning about machines. Well done. You've come to the end of this lesson. Keep practicing what you've learned. I will see you in the next lesson.